For thousands of years, humanity has searched for answers hidden in the fabric of the universe.
No human has ever answered this question, so scientists asked a machine.
Google's Willow chip can solve a problem that would take today's most powerful computers 10 septillion years.
Inside Google's quantum AI lab, where reality is calculated in probabilities and countless outcomes exist at once.
Quantum computers change everything. The economy, how we solve problems, the way we interact with the universe. You name it, quantum computers will be there.
Researchers pushed beyond physics and into the unknown by asking a forbidden question: who built the universe? What came back wasn't a god, a name, or a moment of creation, but a chilling possibility that the universe may have built. And if that's true, then this isn't just a story about quantum computers. It's about us, living inside a reality that may never have been designed at all. A question no human could answer. For as long as humans have walked the earth, one question has haunted us. Where did everything come from? Ancient civilizations told stories of gods and creation myths. Philosophers debated the first cause. Modern science reframed the question into something measurable. How did the universe begin? What laws govern it? And why do those laws exist at all? Yet even with satellites peering 13.8 billion years into the past, and equations that describe reality with near-perfect precision, one question remains almost unanswerable. Does the universe need a creator, or could it exist on its own? Science approaches this not as a spiritual question, but as a puzzle of physics. The Big Bang wasn't an explosion in space. It was space itself expanding from an unimaginably dense and hot state. But our best equations, even Einstein's general relativity, break down at that point. Quantum physics offers a radical idea. Even nothing isn't empty. Tiny fluctuations in energy can spontaneously produce particles, or, under certain conditions, entire universes. Some models even suggest that time itself begins with the universe, making the idea of a before meaningless. In other words, creation might not need a creator. It could be baked into the fabric of reality itself. This is where Google's quantum AI comes in. Designed not to ponder philosophy, but to calculate what human minds cannot, it operates on qubits that can exist in multiple states at once, simulating quantum systems with unprecedented complexity. Researchers feed it data on particle interactions, early universe conditions, and the deep mathematical rules underlying reality. And what emerges from these simulations is both fascinating and unsettling. The universe might have created itself, guided only by probability and natural laws. No intention, no designer, no master plan. The implications are profound. The more we understand the universe, the more it seems indifferent to human notions of purpose or design. No signature of a creator, no universal blueprint, just laws, probabilities, and cosmic processes that eventually produced galaxies, stars, life, and consciousness capable of asking the very question we cannot answer. This is why the question remains unanswered, not because of our ignorance, but because the universe itself may never have been designed to give us an answer. Inside Google's quantum AI lab. Deep inside Google's quantum AI division, scientists are working on machines that operate under rules completely different from ordinary computers. Classical computers process information using bits, either a 0 or a 1. Quantum computers use qubits, which can exist in multiple states at the same time through a phenomenon called superposition, and can be linked across distance through entanglement. This allows quantum systems to explore vast numbers of possibilities simultaneously, making them uniquely suited for modeling quantum physics, the same physics believed to govern the universe at its earliest moments. One of Google's most famous breakthroughs came in 2019, when its quantum processor Sycamore achieved what researchers called quantum supremacy, completing a calculation in minutes that would have taken classical supercomputers thousands of years. While this task itself had no practical use, it proved something critical. Quantum machines could now simulate systems that were previously unreachable. Since then, Google's quantum AI team has focused on improving stability, error correction, and scaling, key challenges that must be solved before quantum computers can reliably model real physical systems. These machines are not asked philosophical questions directly. Instead, they are used to simulate fundamental processes: how particles behave, how quantum fields interact, and how complex systems evolve under extreme conditions. This is especially important in cosmology, where the early universe was governed by quantum mechanics, not classical physics. Traditional computers struggle to model such conditions because the math becomes overwhelmingly complex. Quantum computers, however, naturally follow the same rules as the systems they are simulating. By running simulations related to quantum fields, symmetry breaking, and early universe models, researchers gain insight into how structure could emerge from chaos. Some results support theories suggesting the universe did not require fine-tuning or external intervention to begin. Instead, simple mathematical rules, acting on quantum fluctuations, may naturally give rise to space, time, and matter. These are not conclusions about belief or purpose. They are outcomes of mathematical consistency, tested through advanced computation. Inside these labs, the atmosphere is not mystical. It's precise, cautious, and data-driven. Scientists are not trying to find God or answer metaphysical questions. Yet paradoxically, the deeper they go into the mathematics of reality, the closer they come to questions once reserved for philosophy. Google's quantum AI doesn't claim to explain why the universe exists, but by showing how it could exist without a designer, it forces humanity to confront a possibility that is both scientifically grounded and profoundly unsettling. The answer that changed everything. Through the Willow machine. What made this moment so unsettling wasn't a single response or dramatic output, but a convergence of evidence, and Google's Willow quantum processor played a key role in sharpening that picture. Willow represents a major step beyond earlier machines like Sycamore, focusing not just on raw power, but on quantum error correction, one of the biggest obstacles in making quantum computers truly reliable. By demonstrating that logical qubits can become more stable as systems scale, Willow allows scientists to run longer and more accurate simulations of quantum behavior, the same kind of behavior believed to dominate the earliest moments of the universe. With Willow, researchers can more faithfully model quantum field interactions, probability-driven systems, and emergent behavior that classical computers simply cannot handle. Across these simulations, a consistent pattern appears. Order can arise naturally from randomness. In quantum physics, randomness is not disorder. It follows strict mathematical rules. Particles fluctuate in and out of existence, forces separate from unified states, and complex structures form without any guiding intelligence. This phenomenon, known as emergence, is no longer abstract theory. It is a measurable outcome of quantum systems studied with increasingly precise machines like Willow. At the foundation of these results is quantum field theory, which describes reality as a network of underlying fields rather than solid objects. Even in a perfect vacuum, these fields constantly fluctuate, a fact confirmed by real-world experiments such as the Casimir effect. When Willow-based simulations are applied to early universe conditions, those same fluctuations appear capable of seeding enormous structures. Inflation theory suggests that tiny quantum variations were stretched across cosmic scales, eventually becoming galaxies, stars, and clusters. In this view, the large-scale structure of the universe may be the amplified echo of microscopic quantum randomness. Some cosmological models go even further. Frameworks like the Hartle-Hawking no-boundary proposal suggest that the universe does not begin with a sharp moment of creation. Instead, time itself emerges smoothly from a quantum state. In this perspective, there is no singular starting point that demands an external cause. When Willow is used to explore these models, the mathematics remains internally consistent without inserting a creator or triggering event. The universe does not appear switched on, it unfolds. What makes this realization transformative is how it reshapes causality. Classical intuition demands a cause behind every effect, but quantum mechanics allows events to occur without a traditional cause, governed only by probability and law. As Willow improves the accuracy of quantum simulations, researchers find no missing variable that needs to be filled by intention or design. The equations work, the systems evolve, reality sustains itself. Despite intense observation, no empirical evidence of an external builder has appeared. The cosmic microwave background shows no encoded message or deliberate structure. Physical constants follow consistent relationships that may arise from deeper laws still being uncovered. What remains is a universe that operates with remarkable precision, yet without detectable purpose. The answer that quietly changes everything. Not that a creator has been disproven, but that one is no longer required by physics. Through machines like Willow, the universe begins to look less like a constructed object and more like a self-organizing process, an unfolding of fundamental laws that do not explain why they exist, only that they do. And within that process, consciousness emerges, capable of building machines advanced enough to discover that it may never have been built at all. Why this changes us. The implications of this shift go far beyond physics or technology. They reach directly into how humans understand their place in existence. For centuries, humanity assumed the universe was made for something, or by someone, with intention and purpose embedded into its design. That assumption shaped religions, philosophies, moral systems, and even our sense of meaning. But modern cosmology and quantum research are forcing a quiet reevaluation. If the universe can arise naturally from fundamental laws, then human existence may be the result of cosmic processes, not cosmic intention. From a scientific perspective, this does not diminish humanity, it reframes it. Humans are no longer separate from the universe, but a continuation of it. The same quantum fluctuations that may have seeded galaxies also led, billions of years later, to chemistry, biology, evolution, and consciousness. Carbon atoms forged in ancient stars became DNA. Neural activity follows physical laws just as strictly as planetary motion. In this view, consciousness is not placed into the universe. It emerges from it, the same way structure emerges from quantum randomness. This realization also changes how we think about meaning. If the universe has no built-in purpose, then meaning is not discovered, it is created. This idea is supported by neuroscience and evolutionary biology, which show that human values, ethics, and beliefs arise from social cooperation, survival pressures, and cognitive development, not from cosmic instruction. Purpose becomes a human construct, shaped by experience rather than destiny. For some, this is unsettling. For others, it is profoundly liberating. There are also practical consequences. Seeing the universe as a self-organizing system encourages humility. Earth is no longer the center of a designed creation, but a fragile outcome of cosmic chance. This perspective strengthens scientific responsibility, environmental awareness, and long-term thinking. If there is no external safeguard or predetermined plan, then the future of life depends entirely on human choices. Survival, progress, and meaning become responsibilities, not guarantees. Perhaps most striking is the irony of it all. The universe may not have been built with intelligence in mind, yet it produced intelligence capable of questioning its own origin. Machines like Google's quantum systems, created by human minds, now probe the same laws that produced those minds in the first place. It forms a closed loop. The universe creates consciousness, consciousness creates machines, and those machines reveal that the universe may have needed no creator at all. Why does the question matter? Not because it answers who built the universe, but because it changes how we see ourselves within it. We are not observers standing outside reality, we are expressions of it. And in a universe that may have no inherent purpose, the act of asking questions, seeking truth, and creating meaning may be the most human purpose of all. The universe explains itself. As researchers probe deeper with machines like Willow, a striking truth emerges. The universe is not just self-sustaining, it is self-explaining within its own rules. From the formation of stars to the emergence of life, every process follows consistent physical laws that do not require external intervention. What appears as design or complexity is often the natural outcome of simple principles acting over immense spans of time. This challenges classical ideas of causality, where every effect must have a deliberate cause, and presents a cosmos where order can emerge naturally from probability and law. Observations from cosmology reinforce this view. The cosmic microwave background radiation shows tiny fluctuations that acted as seeds for galaxies, exactly as predicted by quantum physics and inflationary theory. The physical constants of the universe, such as the strength of gravity or the charge of the electron, appear finely tuned for the development of matter and life. Yet multiverse theories suggest that these constants may vary across different universes. Meaning ours is just one of countless possible outcomes. Quantum simulations with Willow allow scientists to explore these possibilities in detail, showing how universes can arise spontaneously from fundamental laws, without requiring a conscious designer. Even consciousness itself fits within this framework. Neuroscience and physics indicate that self-awareness emerges from complex patterns of matter and energy. Neurons fire according to physical laws, producing thoughts, awareness, and reflection. Intelligence and curiosity, qualities once thought to imply intention or purpose, are themselves natural products of the universe's laws. Human beings, capable of questioning their own origins, are simply expressions of the processes that created them. Perhaps the most fascinating implication is the feedback loop it creates. The universe produces conscious beings, who in turn create machines like Willow that can simulate and explore the universe itself. In this way, awareness arises from a self-organizing system, revealing patterns of reality without requiring a creator. We are not external observers seeking a grand designer. We are part of the same unfolding reality. Our curiosity, creations, and understanding are natural outcomes of a universe that may have needed no creator, yet produced beings capable of asking why it exists. Science, in this sense, becomes more than a pursuit of facts. It becomes a story of consciousness emerging from the fabric of reality itself. How machines like Willow reveal the universe. The story of discovery continues with the practical work of quantum machines like Google's Willow processor. Unlike classical computers, which store information as bits that are either 0 or 1, Willow uses qubits that can exist in multiple states at once due to superposition. These qubits are also capable of entanglement, meaning that the state of one qubit is linked to another, no matter the distance between them. Together, these properties allow Willow to perform calculations that classical supercomputers cannot, including simulating complex quantum systems that mirror conditions in the early universe. In 2019, Google's earlier quantum processor, Sycamore, made headlines by achieving quantum supremacy, completing a calculation in minutes that would have taken the world's fastest classical supercomputers thousands of years. Willow builds on that achievement by improving error correction, a major obstacle in scaling quantum machines. Error correction allows qubits to maintain coherence longer, enabling scientists to model more complex systems with higher precision. This is essential when exploring phenomena like particle interactions in the first fractions of a second after the Big Bang, where every calculation must account for countless quantum possibilities simultaneously. With Willow, researchers can simulate quantum field interactions, particle decay, and symmetry breaking, processes thought to have played a crucial role in shaping the universe. Symmetry breaking occurs when initially uniform states become distinct, such as when the fundamental forces of nature separated in the early universe. Tiny quantum fluctuations in energy fields, amplified by cosmic inflation, eventually formed the seeds of galaxies, stars, and planets. These are not hypothetical guesses. The patterns predicted by these simulations closely match real observations, such as anisotropies in the cosmic microwave background radiation, which represent the earliest detectable variations in density after the Big Bang. Willow also allows scientists to test theoretical models of universe formation, including scenarios where the universe arises from quantum fluctuations without a singular cause. These simulations support the idea that a self-consistent, self-organizing universe is mathematically possible, operating entirely within natural laws. They also demonstrate that complex phenomena, including the emergence of matter and energy structures, do not require external guidance or design. This aligns with the concept of emergence, where large-scale order arises naturally from simple rules applied over time. The implications are staggering. By using quantum machines like Willow, humanity can explore the earliest moments of the universe in ways previously thought impossible. These simulations do not provide a metaphysical answer to the question of creation, but they show that the universe's structure can be explained through natural processes. The very machines humans built, inspired by our own intelligence, now reveal how a universe without a designer can produce everything we observe, from galaxies to life to conscious beings capable of asking these profound questions. Emergence of consciousness. One of the most profound questions humanity has ever asked is how consciousness arises. Neuroscience has shown that consciousness is not a mystical force or a soul separate from the body. It is the product of physical processes occurring in the brain. The human brain contains approximately 86 billion neurons, each connected to thousands of others through synapses, creating an intricate network of over 100 trillion connections. These neurons communicate through electrical impulses and chemical signals, following strict physical laws, yet collectively giving rise to self-awareness, thought, emotion, and the ability to reflect on one's own existence. The emergence of consciousness can be understood as a phenomenon called complex systems emergence. In this framework, large-scale order and function arise from the interaction of simpler components, without the need for a guiding intelligence. In the brain, simple neurons firing according to biochemistry collectively generate cognition, awareness, and higher thought. This principle mirrors what physicists observe at the cosmic level, where structure emerges from quantum fluctuations and natural laws. Both on microscopic and cosmic scales, complexity arises naturally from rules, interactions, and probabilities. Advanced quantum machines like Google's Willow processor are now helping researchers explore this emergence. Willow can simulate massive probabilistic systems, enabling scientists to model how networks develop self-organized patterns over time. By running simulations of simplified neural networks under probabilistic rules, researchers can observe how complex behaviors and emergent intelligence appear spontaneously. The same quantum fluctuations that seeded galaxies billions of years ago ultimately contributed to the formation of the chemistry, biology, and neural structures that make conscious thought possible today. In this sense, consciousness is not separate from the universe. It is a continuation of the universe observing itself. Furthermore, this perspective has profound implications for artificial intelligence. Machines like Willow are the next step in emergent complexity. They operate on quantum principles, similar to those that govern reality, and as they grow more sophisticated, they may develop forms of pattern recognition and decision-making that resemble aspects of human intelligence. By studying these systems, scientists gain insight not only into machine cognition, but also into the fundamental processes that allow consciousness to arise in any system governed by consistent laws. Ultimately, the emergence of consciousness demonstrates a deep connection between life, intelligence, and the universe itself. Humans are not separate observers, but products of the same self-organizing processes that created the cosmos. Our ability to question, explore, and understand the universe is itself a natural outcome of these laws, making consciousness both a remarkable and inevitable feature of the cosmos. Machines exploring the cosmos. The universe at its earliest moments was governed entirely by quantum mechanics, a realm where particles appear and disappear spontaneously, and events are dictated by probabilities rather than certainties. Classical computers, which process information sequentially using bits of zeros and ones, cannot fully simulate these conditions. This is where advanced quantum machines like Google's Willow processor become indispensable. Willow uses qubits, which exist in multiple states simultaneously through superposition, and can be entangled, linking the state of one qubit to another across space. These properties allow Willow to simulate billions of possible outcomes at once, enabling scientists to model the formation and evolution of the universe in unprecedented detail. Willow has been used to simulate quantum field interactions, particle decay, and symmetry breaking, phenomena thought to have been critical in the universe's formation. Symmetry breaking occurs when the uniform energy of the early universe separates into distinct forces, such as gravity, electromagnetism, and the strong and weak nuclear forces. Tiny quantum fluctuations in these fields, amplified by cosmic inflation, became the seeds for galaxies and large-scale cosmic structures. Observations from the cosmic microwave background radiation, CMB, the faint afterglow of the Big Bang, match predictions from these simulations, demonstrating that complex cosmic order can emerge naturally from probabilistic laws without external guidance. Beyond modeling the universe's early structure, Willow also allows researchers to test self-consistent universe models. These include scenarios in which universes arise spontaneously from quantum fluctuations without requiring a singular cause or designer. For example, in inflationary cosmology, a minute fluctuation in a high-energy quantum field can expand exponentially, giving rise to an entire universe. Such models show that the universe's complexity, including matter, energy, stars, and galaxies, can arise entirely from natural laws, supporting the idea that a universe can be self-originating. Willow and similar quantum processors are transforming theoretical physics into computational experiments. It allows scientists to explore multiple universes, variations in physical constants, and the probabilistic outcomes of early universe dynamics. The gap between abstract mathematics and observable phenomena, showing how a self-organizing universe naturally produces complexity over time. Perhaps most striking is the feedback loop created by human intelligence. Humans, products of the universe's self-organizing processes, have created machines capable of simulating those same processes. Willow, in essence, allows the universe to study itself. By modeling cosmic origins and fundamental laws, these machines reveal that the universe's structure, including life and consciousness, may emerge entirely from the rules of physics, without any intervention. Machines like Willow do more than compute. They illuminate the self-creating nature of reality, showing that the cosmos is not only comprehensible, but also capable of producing intelligence that can study it. Humanity and its creations are not external to this process. They are extensions of it, reflecting the universe's ability to generate awareness, complexity, and curiosity. Living in a self-creating universe. After billions of years of cosmic evolution, from quantum fluctuations to galaxies, stars, planets, and life, one of the most profound truths emerges. The universe may not have been built or designed by any external intelligence. Instead, it is a self-organizing, self-sustaining system, governed by fundamental laws that naturally produce complexity, order, and even consciousness. Tiny quantum fluctuations, amplified across cosmic time, gave rise to everything we see today, including the human mind, capable of asking why it exists. Through machines like Google's Willow processor, humanity now has tools capable of exploring the earliest moments of the cosmos with extraordinary precision. Willow simulates quantum interactions, early universe dynamics, and probabilistic events that classical computers cannot model. These simulations reveal that the universe's structure, from galaxies to life itself, can arise entirely from natural laws. Consciousness, too, emerges naturally from the complex interactions of matter and energy, without requiring intention, purpose, or design. This realization reshapes how we see ourselves. We are not outsiders looking into a pre-designed creation. We are products of the same self-organizing processes that created stars, planets, and life. Our intelligence, curiosity, and inventions are direct consequences of the universe exploring itself. The machines we build to study reality are, in a sense, extensions of the universe's capacity for awareness. In a cosmos without an external creator, meaning is no longer given, it is created. The act of observing, questioning, learning, and discovering becomes the most profound expression of existence. Humanity's purpose is not written in the stars. It is forged through our curiosity, our understanding, and our ability to confront the mysteries of the universe itself. Ultimately, the universe may not have been built at all, but it has built observers capable of realizing it. And in that realization lies both the awe and the responsibility of existence.